Okay, a very brief look at Calculus 12. We're going to do a limit problem. So the first thing we want to do is plug that -1 in. So it's going to look like this. 2 times -1 squared plus 3 times -1 plus 2. You can do it with the arithmetic, or you can plug it into the calculator. It doesn't matter. It's calculator active. So if you don't trust your arithmetic, 2 times -1 squared plus 3 times -1 plus 2. And it kicks out 1. So I'm going to trust that as my answer. Equals 1. Limit as x approaches 4 pi over 3 over of cotangent x. So all that means we're going to plug in 4 pi over 3 in the cotangent. So I need to find out what cotangent of 4 pi over 3 is. So let's go to our chart. Cotangent, scroll across till we get to 4 pi over 3. It's the bottom row here, scrolling across until I get to 4 pi over 3. So cotangent of 4 pi over 3 is going to equal root 3 over 3. Not that big of a deal if you have the chart. So that's going to be root 3 over 3. So this time I'm going to plug in -1/2. I'm definitely going to want to use the calculator for this. So this is going to equal -1/2 squared plus 4 times -1/2. If you want to, you can convert that to a decimal if it's quicker for you to type in. So let's try this out here. We're going to do -0.5 close parentheses squared plus 4 times -0.5 and -7 over 4. If you want to find the decimal, that's okay also. So -1.75 or -7/4. Either is acceptable. This one, not that big of a deal. You plug the 2 into the x, so 5 times 2 equals 10. The arithmetic wasn't that much of a challenge. Average rate of change, average rate of change, average rate of change. This is the x value, and this is another x value. So I'm going to put those x values on the bottom of the slope template. So it's going to be x sub 2 minus x sub 1. So that would be 4 minus 1. Now, what I want to do is plug this 4 into this equation up here. So 3 times 4 is 12. 12 plus 2 is 14. Then I'm going to plug the 1 in. I'm going to plug that 1 in. So 3 times 1 is 3. 3 plus 2 is 5. So we're going to do our arithmetic. Again, you don't have to use the calculator if you don't want to, but 14 minus 5 on the top over 4 minus 1 on the bottom. And that gives us just 3. So yeah, 9 over 3 is 3. Same song and dance over here. Same song and dance. So this is the x sub 1. This is the x sub 2. So in the slope template, it's going to be y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So that's going to be 5 minus 2 on the bottom. Now I take that 5 and plug it into x squared. So 25 minus 3 is 22. Plug that 2 in. 2 squared is 4. 4 minus 3 is 1. Again, you can do the arithmetic by hand or use the trusty calculator. Hit the fraction bar, type in 22 minus 1, down arrow, 5 minus 2, and that's going to give us the 7. And if you did it by hand, that would be 21 over 3. 21 divided by 3 equals 7. Power rule derivative, 5 times 7, so that's going to be 35x to the 4th plus 2. ln and radicals are closely related, okay? So to find the derivative of ln, it's going to equal a division bar. And you just copy this down. 7x to the 5th plus 2x. And then for ln, the derivative of the guts goes on top. So 35x to the 4th plus 2. That's your derivative. Square root. The derivative of a square root is also a fraction. Also copying. Square root, 7x to the 5th plus 2x. Here's where it's a little different. Inside there's a hidden 2 in the square root. That 2 comes outside the radical when you write it on the bottom. And then what goes on the top? The derivative of the guts goes on the top. So the derivative of 7x to the 5th is 35x to the 4th plus 2. So that's that derivative. Product rule. Crack it down the middle like an egg. Set up a T-chart. The derivative of 5x to the 7th is 35x to the 6th. The derivative of e to the x, recall, is itself. Crisscross applesauce. 5x to the 7th times e to the x plus 35x to the 6th times e to the x. Antiderivative. For number 11, the antiderivative can be done totally in the calculator. Totally done in the calculator. So let's set it up. First thing you're going to do is make sure you're in mode 1. Normal computational mode. And then, to get this symbol to appear, you're going to hit this button right here. Just hit it. And ta-da. Don't hit the arrows. You want to keep it in the big rectangle. And you're going to type in 8 and then alpha. Alpha red x. See the red x? Right there at the parentheses. Alpha red x. That generates an x. Then we have to cube it. To get a cube, you're going to hit the x box. Once you hit the x box, you put a 3 up there. Now, I'm going to come down to this lower box here and enter this 0. So you're going to down arrow, put a 0, up arrow, put a 4, and hit equals. It'll do it for you. 512. Look at it go. You can't do that for this one. Here's the deal. Written on my walls is the note. Secant, secant, tan. Cosecant, negative cosecant, cotan. 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 This is a very powerful note. So because I have negative cosecant, cotan, I'm going to write this down. Cosecant, negative cosecant, cotan. Now to find the antiderivative of negative cosecant, cotan, notice how they're right there? You just hide these two. And it points to cosecant. So the antiderivative of that is cosecant. Evaluate it from pi over 2 to 2 pi over 3. Now I have to find out what cosecant of 2 pi over 3 is. Go to your chart. Cosecant of 2 pi over 3. Cosecant of 2 pi over 3. Cosecant of 2 pi over 3. There's 2 pi over 3. There's cosecant. They meet up at 2 root 3 over 3. So this is going to go to 2 root 3 over 3. Now I have to find out what cosecant of pi over 2 is. Cosecant of pi over 2. Find pi over 2. Find cosecant. Pi over 2 and cosecant meet up at 1. So that's going to go to 1. Here it comes, the fundamental theorem of calculus. 2 root 3 over 3 minus 1. You aren't going to do it on the calculator. Good luck.